Welcome back to this new restart tutorial. In the previous video, we had an overview of the framework which will allow us to fast create REST APIs based on MongoDB. In today's video, we're going deeper into different topics, starting from the setup and the configuration. As always, our starting point is the restart.org official website, where we can find the complete documentation. In particular, we start from Get Started, where we can find the setup page with all the necessary instructions to make our restart instance operational in a very short time. There are essentially three ways to do that. The first one requires the use of a compiled code which we can find on the website and which we can download in the form of a compressed archive. We have the two links here. As we will see later, there is also the chance to use a Docker image. For experts, there is also a third option, which is to compile the source code. We will go through this first way quickly because we already saw it in more detail in the previous video. You can find the link in the description below. So, after downloading the compressed file, we have to unpack it. This is the typical structure. We can see that we have a main file called restart.jar. We also have an etc folder, which contains all the configuration files, which we will later see in more detail. Finally, we also have a plugin folder. This contains all the plugins that we need to implement the framework functionalities. In fact, this is a plugin architecture. This means that we can add new functionalities through specific plugins. The two plugins that we see here are the core plugins. That means that they allow us to realize the main functionalities. That is, the interaction with MongoDB and the management of security. Talking about prerequisites. At least Java 11 must be installed on our computer, and obviously a MongoDB instance too. In the example, we talk about MongoDB running on the local machine on the port 27017, because these are the default settings. Later, we will see in the configuration file how it is possible to modify this configuration, possibly to use another instance that runs somewhere else, also in the cloud. As we already saw in the other video, the command to execute is java-jar restart.jar etc/restart.yaml -e etc/default.properties. So, we execute the restart.jar file, and we pass the restart.yaml configuration file. Since this file contains some parameterized properties, the values of these parameters are specified inside the default.properties file. The second way to use restart is based on Docker. We have an image that we can easily download from Docker Hub. In fact, this is the page on Docker Hub. Let's take a look to the Docker file to understand what is inside the image. As we can see, we start from a base image which adopts the 11th version of OpenJDK. Then, a /opt/restart work directory is simply created, where the configuration files we previously saw are copied inside /etc. The restart.jar file and the two plugins which interact with MongoDB and which manage security are recovered from the target folder. These are then saved inside the /opt/restart/plugins folder. In short, the same structure we already saw is replaced inside the image by using two compressed files that can be downloaded directly from the official website. Then, there is obviously the command to start the application, that is the classic java-jar with the file restart.jar and the properties configuration file. In this case, they are relative to the default.properties file. Finally, also the doors necessary for the good functioning of the application are exposed. Next to the Docker image we already saw, there is something even more useful. That is, the possibility to use the Docker Compose file, which allows to build all the necessary infrastructure to make restart work. So, not only the container related to restart, but also a container related to MongoDB. This way, we can set up everything we need without having to download and install anything on our computer. Let's take a look to the file directory on GitHub so that we can understand how it works and how this infrastructure is created. We obviously need Docker and Docker Compose already installed on our computer, and at least a basic understanding of the Docker Compose notions in order to find our way inside the configuration file. As we can see, a restart backend network is created to allow the containers to communicate with each other. These containers are the restart that is generated starting from the image we previously saw, and MongoDB, which is created starting from a 4.2 version of MongoDB's official image. As we can see, inside the restart service, there is one environment variable that is MongoUri. This sets the connection string to MongoDB. The use of the environment variables is necessary to override the default settings we find in default.properties. Without them, values found inside that file would be used. We can also see that this container depends on MongoDB. The network we previously set and the exposed doors are pointed out. This works in a similar way for MongoDB. In this case too, we have some environment variables to address the root user. There is also a volume in order to make the data inside the database persistent. Remember that in a container, the system file's life is limited to that of the container itself. So, when the container is destroyed, we lose all the data inside it. In order for them to survive when the container dies, it is necessary to create a volume. Here we have an initial string. Therefore, we do not go further into details. Instead, let's go to the console and see how to start our infrastructure. First, we have to download the Docker Compose file from GitHub. I copied the command that was on the website page. Let's use curl to download the file and let's save it on our local machine by naming it docker/compose.yaml. Here it is. If we make a list of all the files, we find docker/compose.yaml. We just have to execute sudo docker compose app. This way, the images found inside the Docker Compose file are downloaded. In my case, I already installed them previously. Therefore, these images are already there, and the boot time will be shorter. If the images are not already in the machine, once you do the first start, you will have to wait some time to allow the download. The time it takes to do this operation depends on the connection speed. So, now we can boot Docker Compose app and wait a few moments till the process is completed. All the operations are recorded in the log files. Restart is now running. We can take a look at the containers and the networks that have been created through Portainer, the tool I use to manage all the Docker containers in my computer. In fact, if we select Containers, we can see that two new containers have been created: Restart and Restart Mongo. These are the images and these are the Docker internal IPs. If we go inside the network, we should also find our network called Restart Backend. Then, inside the volumes, we see Restart Mongo Volume. In short, we can find all the elements which have been generated from the Docker Compose configuration file. The last option is to recompile the source code by downloading it directly from GitHub's official repository. This option is for those who are more experienced, since it requires some familiarity with the Java language, JDK, Maven, and the compilation of Java codes. But why compiling everything from scratch? Well, because this allows to test the latest available version of the code, which will not be the same as the latest released version. In general, between two releases, the code undergoes a series of changes in order to fix bugs and to add new functionalities. Therefore, recompiling everything allows to verify if certain problems have been solved and if new functionalities have been added. Moreover, it is very useful if someone wants to test the code and take part in the development. After all, this is an open source project and therefore it is open to everyone's contribution. In fact, the goal is to have more collaborators and developers, both on the testing side and on the development of new functionalities, as well as for general improvements of the code. Let's now see how we can recompile the code on our computer. First of all, we make a Git clone of the repository. This creates a restart folder and downloads the entire source code. Now we move in restart and we write the command mvn clean package. Now the code compilation starts. Since I already did this operation before, dependencies are not downloaded because they are already inside this computer. When you do this operation for the first time, you will see that all dependencies are downloaded and therefore the operation may take longer, also a few minutes, depending on the speed of your connection. In my case, the compilation of the code takes only 30 seconds. If we look at the structure, we see the core directory. And here we will find the target directory. Inside this last one, there are the files we are looking for. In particular, we find the following files: restart.jar and plugins, with the two Restart MongoDB and Restart Security plugins. This is the same structure we saw before. Now we just have to start restart.jar and specify the position of the two configuration files, which are restart.yaml and default.properties, or any other .properties file which contains the values of the different properties. Now we can take care of the configuration. Let's remember that the main configuration file is restart.yaml, which, as we already said, has some properties parameterized using the Mustache format. Let's look at it directly on GitHub. This is the restart.yaml file, which is organized in different sections. Each of them covers a specific area. Here we can see the Mustache format, which is represented by those three curly brackets. So, how does it work exactly? Well, HTTPS listener or HTTP host represents the property. In this case, the value must be taken from a .properties file. Since there is the default.properties file, we can see the values associated to the different properties. So, this is the structure we can see in the .yaml file. Name of the property, column, the parameter in the Mustache format, that is with the three curly brackets, and the name of the parameter. The name of the .properties file is arbitrary. In this case, it is called default to show the default settings, but we can also have div.properties, production.properties, and so on. In this way, we can have different configurations to choose from in the startup phase. Here, the values are assigned in this way, that is, by writing the name of the parameter, such as HTTP listener, the equal symbol, and the value. When the restart instance will start, the different parameters inside the .yaml file will get a value from the .properties file we specified in the command line. Let's take a quick look. We have the section of the listeners, where we can set the host related to the different protocols such as HTTP, HTTPS, and AGP. Here we can specify the name we want to give to the instance. Let's skip for now the part related to the proxyed resources, since this is an advanced topic and we may cover it in the future. What is interesting for us is the part related to MongoDB. We can specify the connection string to the MongoDB database. The default one is MongoDB 127.0.0.1. This means that, by default, it is required to have a running instance on our local machine using MongoDB's default port, which is the 27017. If we have an instance on a provider such as Atlas, AWS, or somewhere else, even on another machine in the local network, then we have to go and specify the correct string here, with the IP of the machine where Mongo is running as well as the door used, in case it is not the default one. Let's move on. The database will be mounted directly on the slash and therefore on the root. Then there is a selection dedicated to the different authentication mechanisms. These can be based on token or token JWT, or can be done through the basic authentication with the various authentication based on files or on MongoDB. However, we will go deeper on this topic in another specific video. This is the part dedicated to the security, which is also the trickiest part. In short, this is the structure of the configuration file, and we have the chance to define more .properties files. In fact, on GitHub, we can see two .properties files, the default and the dev, which has different properties. Let's talk briefly about the two files related to the security too. The security is based on a list of users found inside the user.yaml file. We also have the ACLs defining the access control lists that specifies the privileges of the different users. This topic will be discussed in more detail in another specific video. If we go back to the official documentation, we can find everything that we just said. As I was saying before, when we start restart.jar and we specify the configuration file, with the -e option we can indicate the .properties files that we want to use. This is the file containing the values of the parameters associated to the configuration file. We can then have different options so that we can manage different configurations in the development, test, and production phases. To conclude this video about the setup and the configuration, let's talk about the logs. Logs are fundamental to track what is happening inside our application, both in the debug and the production phases. It allows to track the different activities and it can be useful to detect intrusion attempts, errors, and malfunctions. So, everything that is useful for the correct operation of the application. From a technical point of view, Restart is written in Java. Therefore, it uses the logback tool for the logs. Those of you who are more technical will find all the details directly on the official website. This configuration is obviously specified inside a file called logback.xml, where the patterns of the messages which will be displayed is structured. There is an indication of the time, the thread, and the level too, as well as the information related to the different messages and the loggers. In this case, the loggers monitor the classes related to the org.restart and com.restart packages. We do not spend much time on this part because, as already mentioned, it will be interesting only for those of you who are more technical and wish to personalize the application more. In fact, this requires having some basic knowledge of Java and the tools that we mentioned. What is interesting for us is the part related to the configuration inside restart.yaml. What is it that we have to set up for the log to work correctly? Here we can see which are the available properties. We have the Enable Log Console property set on True, which makes sure that we can see the different log messages scroll inside the console. Obviously, this mode does not allow us to track everything that is happening because the logs do not have any persistence. Therefore, it is more convenient to have a saving of the logs directly on a file, so that this data will be still available for future analysis. In order to activate this option, we have two properties, that is, the Enable Log File, which is set on false by default, and the log file path, where we specify the position where the log file must be saved. By default, the log file will be called restart.log. Then we can specify a growing level of the logs. We can include all the information related to the logs or simply stop at the warning or error messages to gradually level up and move to debug, trace, and all. By moving from left to right, the number of the log messages displayed increases. Therefore, the choice of a level rather than another depends on the context. It's clear that during the debug and testing phase, it will be necessary to work on a higher level, also to be able to study everything that is happening. Now we will do some tests to see the different log types. First of all, we go and check the configuration file, that is the default.properties, to see the settings of the logs properties. We see that the Enable Log console is set on True. Therefore, the console logging is enabled. Also, the log on the file is enabled, and the log file is restart.log, and the log level is debug. So, we will have both the log on the console and the log on the file. Let's move to the root and let's start restart. We already see the messages. We have different colors. As we saw before, there are different levels, and when we have the debug level, we will still see the info and the warning with different colors. The debugs are white, the infos are blue, and the warnings are red. Now, let's see the log file that was generated. Here it is. It is the restart.log file. As we can see, inside the file there are all the log messages that we saw before. This allows us to analyze everything that happened during the session, looking for any errors or problems which can be easily detected. Here there is something to notice. This file contains get calls that we did not do during this session. This simply happens because the restart.log file is not restored with every new reboot of restart. The new logs are simply queued in the file. This gives us a record of everything that happened. At the same time, this allows us to see some interesting information. What we just tested is simply the start of restart. We didn't do any interaction with the database. On the other hand, all the information related to the calls are recorded too. Therefore, we can also have an overview of all the connection attempts of the users that did or did not authenticate, in order to see if there were problems or intrusion attempts, for example, from computer hackers. Let's take a quick look at those rows. Here, for example, there is a request for the users list. We will talk about this kind of call in more detail in the video about security. However, it is enough to remember that when the user's management is activated through MongoDB, all the users of the system are found inside a specific collection, which by default is the collection named users. So, the call to this endpoint should give us the users list. Therefore, we can see here that there is a get done to this endpoint to get the users list. There is the indication of the source. In this case, it is the local IP address, but in a production context, there you will see the IP of the client who did the request with his port number. As we can see, there is also information about the authentication mechanism used. In this case, it is the basic authentication mechanism, that is the one based on the username and password credentials. So, the log on a file is very useful for this kind of analysis. That's all for now. In the next video, we will talk about security and we will analyze in detail how Restart security mechanism works. See you soon!